Okay, so this is the first in a specialized series on variant Sudoku. I have bookmarked this site. This is called missingdeck.net, and this is GAS or Genuinely Approachable Sudoku collection number one. I found these variants, which are a little more than classic Sudoku, so they have a little more rules beyond just the normal 1 to 9 in every row, column, and box. But these are not quite as complex as what is seen on, say, the cracking the cryptic, say that 3 times fast, that Mark Goodliffe and Simon Anthony produce out of the United Kingdom. I will try and get to those eventually, and since they're up to about 700 puzzles, I have about 2 years worth of content that I can try. But I figured since I'm not quite as good at scanning the board just yet, I thought I'd try some of the easier ones first. I'll post a little more about this in an introduction video, but you are talking to a walking, talking medical miracle and listening to one. I'm not always going to be around to do these things live, so sometimes I will pre-record things so I can post them on days where I'm on travel or I have surgery and need some recovery time, for instance. Now, with that out of the way, let's start with this first one. This is called Losing Our Religion. According to the people who originally made this puzzle, it's straightforward scanning and or killer cage practice. Now, it also appears in their gas collection, not surprising because it shows up on a website with the same name. Okay, this says solving the Sudoku Pad app with Solution Checker. So what I'm going to do is I'm going to open this thing. Okay, so what this is saying is normal Sudoku rules. Every row, column, and box must contain a complete set of digits 1 to 9. That's normal classic rules. Then normal killer cages. Digits in cages cannot repeat and must sum to the total shown in the upper left corner of the cage. So, 1 to 9 has to appear in every row, one of these, every column, one of these, and every 3x3 box, one of these highlighted dark blue cells or regions. Now, in killer cages, all that says is these 3 cells add to the top left corner given, in this case 6, and they cannot repeat. This seems fairly straightforward enough. Now, what's going to be unusual for me in this particular puzzle is there's only one given digit. And supposedly with math, and just that 1 3 in the corner, you're going to be able to uniquely solve this puzzle, i.e. fill in the other 80 given digits to complete the 81 digits in the 9x9 grid shown here. So, with that, let's get this show on the road, shall we? Okay. A 3-cell cage, it adds to 6. Well, obviously it has a 3 in it. And the reason it has to have a 3 in it is it cannot have a 4. If a 6-cell cage contained a 4, you'd be stuck with 4 1 1. Now, you can't do that without violating killer cage Sudoku rules, because you can't have 2 1s in the same cage. Now, there's another concept in math, what they call the triangular number, and triangular numbers are just 1 plus 2 plus and so on, each positive integer incrementing by 1, and then you sum them up. So the triangular number for 1 is 1. The triangular number for 2 is 1 plus 2, which is 3. The triangular number for 3 is 1 plus 2 plus 3, which is 6. So I happen to know that 1 plus 2 plus 3 is 6, and there's a 3-cell cage. Therefore, these 2 cells must be 1, 2. And I accidentally switched grids there. Okay, so these are a 1, 2 pair. Now, let's think about what that means. I don't know much about the other cells, but I do know that this is a 20 cage with 3 cells in it. Now, does it necessarily have to contain a 9? Not really. Because 8 plus 7 plus 6 gets you to 21. So 875 gets you to 20. 9 plus 8 plus 3 would also get you to 20, but I've already eliminated the 3 because it's given. So, but 974 also gets you to 20. 965 also gets you to 20. So we have 965, 974, 974, 965, or 857. But I'm not entirely sure how to mark that. Let's see what else I can do. Okay, this 3-cell cage summing to 7, I think that has to be 124. I don't think it could be anything else. This 6 cage summing to 3 is also another 123 set. Let's see, 8 in 3 cells. Could be 431, actually. Now, does 8 in 3 cells have to contain a 4? Well, the minimum for 3 cells is 3 plus 2 plus 1 is 6. 322 to make 7 clearly doesn't work, and 323 to make 8 doesn't work either. 3 plus 2 repeats a digit, 3 plus 3 repeats a digit, and in the same cage. So I think 8 in 3 cells, this is forced to be 134, and neither of these cells can be a 3. So I think that has to be 3. And these two are a 1-4 pair. 14 in 2 cells is relatively straightforward. 9 plus 5 or 8 plus 6, that's it. I can't repeat 7, and then you go 6 plus 8 or 5 plus 9, which is just a repeat of what I already said. And if you go 4 plus 10 and so on, well, then you have a double-digit number, and those aren't valid Sudoku digits. So, with 14 now being established as 9 plus 5 or 8 plus 6, this is definitely a 5, 6, 8, 9 set. No, actually, I just thought of something else. If this is 3, 1, and 4 here, 1 must appear in one of these cells, which means it can't appear here, so that forces this to be 1, doesn't it? Forces that to be 1, and that to be a 2. I don't think that can go any other way. Let's see, that 3 looks down here. This is now a 1-2 pair. That forces this to be a 3. That 1 tells me these are 2 and 4. Which forces that to be 1. Okay, that 1 looks over here. This is 2. That's 1. That 2 looks back over here. This is 4. And that's 2. Okay, we have all the corners filled, I believe, now. That 1 looks back up here. This can't be 1, so that's 4, which forces that to be 1. We know these are 5, 6, 8, 9. These 3 must be the digits that haven't been placed yet. They cannot be 1, 2, 3, 5, 6, 8, or 9. They must be 1, 2, 3, 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, Okay, I feel like I have too many digits placed. Because I've got 1, 2, 3, 4, 5, 6, 8, 9. The only thing I'm missing is 7. So these are 5, 6, 7, 8, 9, and we know that these cells can't be a 7. Hmm. Well, that doesn't help with a whole lot. Now, let's see, what else can I do easily? Oh, there's another 6 cage. I know that's 1, 2, 3. But this can't be 2. Oh, actually, that can't be 2 or 1 because of the already placed digits. So that is a 3, which means these are 1 and 2. Whoops. So that's a 1, 2 pair, but that doesn't help me with a lot of anything else, does it? Let's see, 9 and 2 cells. 5, 4, 6, 3, or 7, 2. Well, but one of these two cells must be a 2, which means one of these two cells cannot be a 2, because if this is a 2, it clashes here, and if that's a 2, it clashes here. So 7, 2 is ruled out. 6, 3 is also ruled out because of this 3, I believe. Not necessarily. If this was 6, 3, this has to be 3, so this could actually still work 3, 6 like that. As far as I know, 4 and 5 can appear in either order in this pair. Hmm. Let's see. This is 1, 2, 3. These three cells sum to 20. 20 plus 6 is 26. Now, because 1 to 9 must appear in every row, column, and box, the sum of those digits is always the triangular number for 9, i.e. 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which is always 45. So, with apologies to Douglas Adams and the Hitchhiker's Guide to the Galaxy, the answer to life, use, universe, and everything in Sudoku is not 42, it's actually 45. But I digress. Anyway, that means these three sum to 20, these three sum to 6. These other cells must sum to 19. Now, I'm pretty sure that there's more than a few ways, and 3 cells can make 19 because the average is 6. I mean, if I went from high digits, I have 9 and a pair of things that make 10. Okay, so 8, 2, 7, 3, 6, 4. If I have 8, then I have 2 things that make 11s, which would be 4, 7, 3, 8, 4, 7, 5, 6. Yeah, I have too many other options to make that work. Now, here's another 6 cage. We know what those are. Those are 1, 2, 3, but this cell can't be 1 or 3, so actually that's a 2. These are now 1 and 3. Are there any other easy cages that I can see? Okay, that 7 has to be 1, 2, and 4. But this 2 rules out these being a 2, so that is 2. Therefore, these are not 2. This is a 1, 4 pair. It's a 1, 4 pair looking at that cell there, so actually that's a 3. That's force, which makes that 1. This 1 tells me this cell can't be a 1, so we've also known for ages that's a 4, that's a 1. This cell tells me this can't be 4. Now, if this isn't 4, then this cell can't be 5. See, this 2 looks down here. That can't be a 2. That's a 1, which tells me that's 2. See, 15 and 2 cells is either 9 plus 6 or 7 plus 8. So, like a cribbage hand, it's 6, 7, 8, 9, but here it's actually worth 15 and not 8. Even though I've got two pairs of things that sum to 15. Insert bad cribbage pun here. Anyway, I don't know what that means. Other than, okay, I've got two 8s here, so that may not help. Two cells that sum to 12. It cannot be 6, 6. So it's either 7, 5 or 8, 4, but this 4 tells me it can't be 8, 4, so this is 5 and 7 in some fashion. One of these is 5, one of these is 7. Not much we know, so the rest of this row we can fill in with not 1, 2, 3, 4, 5, or 7. These are a 6, 8, 9 set. "14 in two cells cannot be double 7. This is either 8, 6 or 9, 5. "13 in two cells is 9, 4, 8, 5, or 7, 6. But I don't know much else beyond that just yet. Let's see, 8 in two cells, 7, 1, 6, 2, 5, 3. Well, let's see. Well, this cell obviously can't be 1, 2, or 3. Okay. So this cell isn't 1 or 2 or 3. This cell is thou not the difference between 8 and those cells, so this can't be 7, 6, or 5. This is not 1, so this can't be 7. This isn't 2, this can't be 6. This is not 3, and therefore that can't be 5. So it's not 5, 6, or 7, and 1 and 2 are already looking at it. So in fact, we know that's a 3. That tells me that's a 5. Okay, now these are 6, 7, 8, 9. I wonder if that's going to do anything later. It might. Let's see, these are 5, 3, so these can't be 5 or 3. I don't think I've ruled out anything else just yet. Let's see, 8 in 3 cells. Obviously, you can't have a 9 or an 8 or a 7 or even a 6 because a 6 repeats 1. So an 8 must include at least one 5. Not necessarily. 5-2-1 works, but 4-3-1 also works. Now, if I don't include a 1, I'm left with 2 plus 3 plus 4, and that's 10. So, actually, I don't think these must contain a 5. I do believe these must contain a 1, but the 1 here tells me these cells can't be 1, so this is 1. And what I don't know is whether it's 3, 4. Well, actually, it can't be 5, 2 because that's a 2, so I know these are 3 and 4, actually. And this 3 tells me that can't be a 3, so that's a 4, which tells me that's a 3. Let's see, this is now not 4, which tells me this is not 9. Let's see, that 1 tells me this is not 1, which tells me this is not 7. This 1 and 2 tells me this can't be 1 or 2. Okay, that must be 6. Wait a minute. That's 6. That's 2. There's a 3 here. That tells me this can't be 3, so that's a 4. That 4 tells me this is 5, because 4 plus 5 is 9. We might be getting somewhere. Okay, this is not 5. See, these are 6, 7, 8, 9. Oh, well, that's interesting. I'm going to 6, 7, 8, 9 here. But I've also, more importantly, got a 6, 7, 8, 9 in box 3. Now, I believe what this means, by just extending the pair logic outward to its logical conclusion, is that I have 4 cells in 4 different spots. Therefore, this must be a 6, 7, 8, 9 set. Therefore, this cell is not 6, 7, 8, or 9, because those digits are here. This cell is also not 1, 2, 3, or 4, because they've been placed, or in the case of that 3 given to us. So, in fact, we know that's a 5. I can highlight it right, so I can write in the 5. Okay. Now, okay, this 5 tells me this is not 5, which tells me this is, oh, this is not 9. 5 tells me this can't be 5, and that therefore can't be 9. This 6 is telling me this can't be 6. So 8, 6 there. This now can't be 6 or 8. Let's see, 5, 6, and 8 are looking at that box. So this is not 5, 6, or 8. Okay, that's a 7, 9 pair in this box, which means this can't be 7 or 9. And it can't be 7 or 9, and I just placed the 6, 8, so it can't be those cells either. Therefore, we know that's a 5. That 5 looks down here. This is not 5, therefore this is not 8. Let's see. Okay, 4, 5 is looking in here. This can't be 4 or 5. So this is not 9 or 8. I have to get rid of the complementary digits that sum to 13. That's now a 6, 7 pair, which means this is not 6. It also can't be 5 because they're given 5. So this is 8 or 9. If this is 9, this is 5. If this is 8, this is 6. See, this is not 6 or 7 because I have a pair looking at it. This is 8 or 9. This is 9, that's 6. If this is 8, that's 7. Let's see, that 5 tells me these cells sum to 15. That doesn't tell us anything we don't already know. These 3 cells have to sum to 20 plus 6, 26, subtract that from 45. These three cells are 19. These two thus have to sum to 15 with that place 4. So these two sum to 15. If this is 7, this is 8. If this is 9, this is 6. So it's 9, 6 like this, or 7, 8 like that. So we know that's 6 or 8. That doesn't tell us anything about here yet. The 18 and 3 cells, I still have too much to go with. But row 5 might be my next deduction, I think. I've got an 8-9 pair, and I've got a 6-7 pair, and I have 2 other digits. So I have 6 out of 9 already placed. These cells cannot be 4 through 9 inclusive. These are a 1, 2, 3 set. Now we already know this can't be 1 or 3 because of what's in the box. So that's a 2. This can't be 2 or 3. That's a 1, therefore that must be a 3. Okay, what does that help me with? Well, that 5 has told me that's not 5, so that's 7. These are 4, 9. I don't know much beyond that. These two cannot be 1, 3, 5, 6, 8. These are 2, 4, 7, 9, right? 1, 3, 5, 6, 8 says 2, 4, 7, 9 to fill in the boxes. Now, this is not 2 or 4 because of what's in the column. Therefore, I now have a 7, 9 pair here. These cells can't be 7 or 9, so that tells me that's a 4 because it can't be 9. This, can't be 7, 9, or 4. It must be 2. Let's see, that 4 looks down here. That's a 9 to complete the row. That 9 looks over here. That's not 9. No, that 7 has told me that's a 5 to make that 12. See, this is not 6. No, it also can't be 9 because it's in the box. Okay, so that's 8. Tells me this is not 8. Neither is that. Which doesn't help with a whole lot. Poop. Let's see. Are there any killer cages I haven't done yet? I still have this 18 in 3 cells, which now cannot contain 1, 2, 3, or 4, so its minimum digit is a 5. I now have a 5 and 2 cells that add to 13, which is 6, 7, which is possible, 5, 8, which repeats a 5, or 4, 9, which repeats a 4, and if I go 3, then I end up in double-digit numbers. So this 18 cage, because it must contain a 5, this must be 5, 6, 7. Now, this can't be 6 because of the placed 6. This can't be 5 because of the place 5. So these are 5, 6, 7. That means this can't be 6 because it has to appear in the cage, so we know that's a 9, actually. Which tells me that's a 6. This is not 6. Neither is that. Now, it should be relatively easy, I think, from here, but let's fill in some more candidates. These three cells here cannot be 1, 2, or 9. Now, this one, actually, these two, let's see, this one can't be 4, 6, or 8 by column logic, or indeed 5 or 7 by box logic. So, this one, I think I've eliminated everything except 3. This one has now eliminated 3, 5, 7, 8, and 6. Oh, I've only got one digit left in the box. That's a 4. Okay, this one now can't be 3, 4, or 6 by box, or 5 by column, actually. So that helps a lot, because these two were 7, 8. Therefore, this cannot be 7 or 8. So, this is not 7, which tells me that's 6. This now cannot be 7 because of the pair looking at it, or the 6 that I just placed. Therefore, this must be a 5. That's 7 to complete the cage total. This 6 is looking up here. That's 7. That's 6. Column 3 just needs an 8 to fill it in. So these cells are not 8. This is also not 7 because of what's looking at it. Okay, row 7 has only 3 digits left in it. 5, 8, and 9. But this can't be 5 or 9. No, and actually I should have spotted that easily. That 8 is the only thing left to fill in box 7. This one now can't be 5 by column or 8 because I just placed it in the row, so that's a 9. This is now not 8 or 9. This must be 5. Okay, that 8 looks up here. That tells me this is 9. This is 5. That 9 tells me this is not 9. This 9 tells me this is not 9. This 8 tells me this is not 8. Okay, I now have a 7, 9 pair in the box. Oh, thank goodness. Because this cannot be 7. It must be 8. That forces this to be 7, and the bottom 3 rows are done. Okay, this 9. I have one thing left in row 5. That must be 8. This must be 7 to make 15. This now has to be 6. Is the only candidate possibility left. This can't be 7 by column 6 by row, so this must be 8. Let's see, this is not 7 or 9. So that must be 6, which tells me that's 9. That's 7. Column 1 only needs one digit left to fill it in. It just needs a 6. These two, to fill out column 2, are 4 and 8. But they see column, row, and box where everything else is already filled in. But I have enough of the other digits. I should be able to just write everything in at this point. These three cannot be 1, 2, 3, 6, or 7. 4, 5, 8, and 9 in some fashion along with this one. Now, this can't be 5, 8, or 9. It must be 4. Okay, this is not 4 or 8. So this is 5 or 9. This can't be 4 or 5, but there's no 8 or 9 pointing at it just yet. So this is 8 or 9. Oh, that 4 tells me that's 8. Tells me that's 4. This 8 points over here. That's 9. That's 5. This is also a 7 or a 9. But the 9 tells me this can't be 9, so that's 7. 9, 7, 9, 7. Column 5 just needs an 8. Column 8 needs a 6. Column 9 needs a 9. Relatively straightforward once I figured out the killer case holes.